A decision tree is a well-known machine learning algorithm that can be used for both classification and regression. Decision tree classifies data by asking questions at each node. In this video, I will explain how to work out the decision tree using ID3 algorithm on Python. To explain the ID3 algorithm, we need to understand two very important concepts: entropy and information gain. Entropy is a measure of impurity of a node. By impurity, we mean to measure the heterogeneity at a particular node. And the entropy formula is given by the Shannon entropy here. It is sum of probability multiplied with a lot of probability with a negative sign in front, and take note, is a log 2. For example, if we want to compute the entropy of this table, play tennis, there are 9 yes and 5 no. So the probability for yes is 9 over 14 and no is 5 over 14. Therefore, the entropy of playing tennis is minus 9 over 14 multiplied with log 9 over 14 minus 5 over 14 multiplied with log 5 over 14, and we get 0.94. Next, if we have 4 features that will contribute to playing tennis, they are outlook, temperature, humidity, and wind, then each feature value has its own entropy. For example, we have entropy for sunny, we have entropy for overcast, we have an entropy for rain. Similar for temperature, we have entropy for hot temperature, mild temperature, cool temperature. So we need to compute the entropy for each attribute value, and for the entropy for the entire feature, we need to take away the sum. Next, we need to understand which feature is the best feature to use for questioning at a particular node, and this is done by using a measure called information gain. The information gain is calculated by taking the entropy of the parent minus the entropy for each feature. The feature of attribute that get the highest information gain at a particular node is chosen as the question that splits the data at that node. I know all this sounds very abstract, so let's move to the Python code to explain the ID3 algorithm. First, we import the libraries, and we can compute the entropy of this parent is minus 0.94, as we explained previously. Next, we will import the play tennis data and show the data over here. Next, we will define the entropy function, which is basically just compute the Shannon by the Shannon formula. So for example, if we compute the entropy of the parent, we get 0.94. It's the same as we do by the manual calculation. Next, we define a function to compute the entropy of the attribute. Over here we have two for loop. the inner for loop is to compute the entropy for each value of the attribute. For example, sunny outlook, overcast outlook, and rainy outlook. Then we have another for loop to do the weighted sum. So this will give us the entropy of the attribute. So for example, if you want to compute the entropy for the attribute outlook, we'll get 0.69. And we need to do this for all the features: outlook, temperature, humidity, and wind. Next, we compute the function for information gain, which is basically the formula entropy of the parent minus entropy of the attribute. So we return the information gain for all the attributes and the one with the highest information gain. So if we apply this function to the whole data, and these are the information gain, this is for the outlook, this temperature, humidity, and wind, we can see the outlook has the highest information gain. That's why it is given by here. So the first node, which is the root node, will be the outlook. So once we determine the root is the outlook, we need to split the next level to 3 possible cases: sunny, overcast, and rain, as shown here. So we define a function to do the split for each possible case. So for the case of outlook sunny, this is the subtable. And if we compute information gain for this subtable, there are 3 features: temperature, humidity, and wind. And we can see that humidity has the highest information gain. So we see that this humidity, when the humidity is high, playing tennis is no. When the humidity is normal, playing tennis is yes. That will be the final lift for the second level, as shown here. So for the outlook, which is overcast, we can see that when the outlook is overcast, we can see there is only one possibility, right? When outlook is overcast, it's always yes, right? That's why overcast is only one outcome. Next, we will compute the subtable for the outlook is rain. And in this case, there is still some impurity, so we compute the information gain, and we get this is the entropy for information gain for temperature, humidity, and wind has the highest information gain. So the next level will be wind. So we get there are 2 possibility of wind, weak and strong, and this is a subtable for the wind that is weak. And we see that since all of them are yes, this will be the final lift. And similarly, when the wind is strong, we see that all the play tennis is no, and that will be the final leaf as shown over here. So this complete our decision tree based on the ID3 algorithms. The code for this Python can be downloaded below. If you like to feedback on the video, we welcome your comments below. If you like this video, please share and subscribe to our channel. Thank you.